figure out my problems now. Anyway, let's do this. So the way to solve exponential equations is basically use the power property. You can also switch forms. You can put them in a different. You can take the exponential and put it in log form if you want, and then use change of base to solve. I'm just going to use the power property. I'm just going to take natural log of everything basically, and then use that. So that's what I'm going to do. So for this guy, I might not have left myself enough room here, but 3 to the x equals 17. I'm going to take natural log of both sides and get natural log of 3 to the x equals natural log of 17. And then I guess I'll go over here. Use the power property to get x times natural log of 3 equals natural log of 17. And then divide by natural log of 3. So x is natural log of 17 over natural log of 3. Now, you can jam this into a calculator if you'd like to. I'm going to go ahead and do that. But you should know that I'm actually perfectly happy with an answer like this on a test, for instance, because it shows me that you actually know how to solve the problem, right? And so here, let's go find the answer. I think it's like 1.58. I believe I did this one in the last video, but let's go check this out. So yeah, so we got natural log of 17 close parentheses over the natural log of 3, and we get 2.58. Okay, so let's go write that's our answer. It's about equal to 2.58. So something like that. We can check that, right? I can do 3 to the power of 2.58 and see what we get. Hopefully it is around 17. I rounded up, so it should be a little bit high. So we got 3 to the power of 2.58. Yeah, so it's a little bit high, right? So we end up with, but this is clearly right. Yeah, there you go. That's how you solve these. There's not a lot more to it than that. What I was saying before was that I kind of prefer an answer like this to an answer like this, because to go from here to here, you're literally just jamming something into a calculator. That's not a skill I'm especially keen to make sure you are good at. And if you write this as your answer, then I know that the only way you can get this is by doing this process, right? And the process is the thing I care about. If your answer is just 2.58, and by the way, this is why I can't, this is why I have to see your work rather than just accepting numbers as answers, because you could fiddle around with this and say, all right, well, so if I know 3 to the 2 is 9 and 3 to the 3 is 27, so what if I do 3 to the 2.5 and I get, oh, that's pretty close, but I'm a little too low. So what if I do 3 to the 2.55? That's pretty close, but I'm still a little bit low. And then you just guess it until you get to the 2.58, right? And then you don't really know how to solve the problem. But that's why I can't take an answer, or I can't take just this as an answer. I want to see the process, right? I want to see that your process is good. So anyway, that's why I kind of like an answer like this. So feel free to leave it like this. Don't feel like you have to jam it into a calculator. I have found in the past that students hate getting answers like this. And so if you really want to get a number, go ahead and put it in a calculator. That's fine. Nothing wrong with it, but you don't really need to. Anyway, let's do the next one. So this one is a little bit trickier, right? There's an expression up here. We're going to solve it exactly the same way. We're going to take natural log of both sides. You use different logs if you want, but like I said in the previous video, that's another letter I have to write. ln is only 2 letters, so that is my preferred log base. Take log of both sides. Use power property to pull the 2x plus 1 out. Now be careful to write this like this, parentheses, natural log of 5. Right? Now, if you omit these parentheses here, right, this is technically wrong because the only thing being multiplied here is the 1. So make sure that you're including the parentheses. Aside from just being, getting things precise, it's also really easy if you omit things to a couple steps later when you've forgotten what you did and you go back to look. Now it's written wrong and then you mess up from that. So just be precise when you're doing this. A thing that I have said, I believe in other videos, and I've almost certainly said in other videos, and I will say again, is that the way to go fast in math is to go slow. Be slow and careful and make sure that you're doing all the steps right. And things don't actually take very long. The thing that takes a long time is correcting errors and finding out where things went awry. So if things don't go awry, things go actually pretty quick. It's not too bad. I'm going to divide both sides by natural log of 5 here, and so I end up with them canceling on the left. And again, I know it's weird to divide by natural log of 5 instead of 5. I know it feels kind of strange to do that, but it's just a number, right? I could find that number if I wanted to. I just go jam it in a calculator. It's like 2-ish, a little bit less than 2. I don't have to know what it is, so I'm just going to call it natural log of 5. So we got 2x plus 1 equals natural log of 11 over natural log of 5. And at this point, you could certainly go put this into a calculator and use the decimal approximation for the rest of the problem if you wanted to. I'm not even going to bother doing that. I'm just going to subtract 1 from both sides. So 2x equals natural log of 11 over natural log of 5 minus 1. And then divide by 2. 2 over 2. So x is this messy looking expression, ln of 11 over ln of 5. Oop, getting a little tight here, minus 1 all over 2. Right? And honestly, that's a fine answer. Feel free to stop there if you want to. Again, you can get a number if you want. I will not even bother this time. But if you now I will just to show you how you would put this into a calculator. You got to be real careful when you get like these complicated expressions putting into calculators. So I want to do natural log of 11 over natural log of 5. So I'm going to put that all in parentheses. So natural log of 11 over natural log of 5, right? Because I want to kind of think of that as one piece. And I want to subtract 1 and divide the whole thing by 2. Well, I'm a parentheses short, right? So there's my top. So now I got to put another set of parentheses. And I guess this is a good time to point out the insert function. A lot of students don't seem to know about this. The second function of delete is insert. If you mess up, you don't have to delete everything. You can insert the thing you want to put in there. I'll go close my other parentheses. Close my other parentheses. Sorry, I got to count them. And divide all this by 2. And I get that. Now you could certainly do this in multiple steps, right? It's actually not a bad idea to do this. I kind of like this better, to be honest. Take that and do minus 1, and I'll divide by 2. All right. So you can do it in that way if you want to. I kind of like that better because then if you're trying to fix it, you don't have to go fix a big expression like this. You can just fix the piece that's broken, essentially. So I actually kind of like doing it in multiple pieces. Some people like trying to get it all into one thing. I find it easier to do it like this and in 3 pieces, though, to be honest. Anyway, so we're going to about 0.245. All right, so my answer is about 0.245. Let's go look at it. So about equal to 0.245. Now, if you want to check this, what you would do is you take 0.245 and you put it into here, right? Multiply it by 2, add 1, raise 5 to that power. So I'm going to do that. So take that, I'm going to multiply by 2 times 2, add 1, and do 5 to that power. Now, here's the thing you can do. I don't have to write this as 1.48989. I can do this. I can do 5 to the power of, and then answer, whatever this is. So answer is the second function of the negative sign. Second answer, like that. 11. Hey, there you go. Look at that. We did it. Fantastic. So looks like that one was good. So let's look at another problem. Next page. Ooh, come on, computer. Next page. Okay. So messier. This is actually not really that much harder. It's like a couple more steps than the other ones, but there's really not a lot to do here, or not a lot different to do here, except you got to clean it up a little bit first. So before you take the logs, like power property says this, right? Log base b of x to the p equals p times log base b of x. Notice that what I want to do is I want to take the log of something, right? I don't have any logs in my expression right here. I'm taking the log of both sides of something, or both sides of the equation, And so that means if I take the log of something, or if I take the log of both sides, I have to get the whole side inside the log. So I don't want to take the log yet, because I would have to take the log of all of this nonsense. And that's not just something raised to a power. So I can't use the power property yet, right? So I got to clean it up first so that it's just something to a power, right? It's really important that it's just this, that's all that I'm trying to take the log of, because otherwise the power property doesn't work. So that's what I want to do. I want to clean this up so that I have just the exponential first. So let me do that. All right, so I'm going to add 11 to both sides. So I have 7 times 2 to the 6 minus 4x equals 30, right? I add 11 to both sides there. Divide by 7, and I get 2 to the 6 minus 4x equals 30 over 7. And then we solve the same way. Take log of both sides. I will use natural log, as always. ln of 2 to the 6 minus 4x equals ln of 30 over 7. Use the power property on the left side, 6 minus 4x. I'm going to be careful to write this in parentheses, times ln of 2 equals ln of 30 over, that's not the 7. That's what 7s look like. And then I'll divide both sides by ln of 2. So I get 6 minus 4x equals ln of 30 over 7 over ln of 2. And then again, you could certainly find your decimal approximation of this thing right now. I'll go ahead and do that, right? I did it the other way last time. Let's do that this way. Do that with decimal approximation this time. So we got ln of 30 over 7 over ln of 2. Let's go look at that. So I got ln 30 over 7 divided by ln 2. 2.099. I'm going to call it 2.1. That looks pretty close. So about equal to 2.1. So I got 6 minus 4x. Now we can go about solving this a variety of ways. I'm going to subtract 6 and then divide by -4. So subtract 6, we get minus 4x about equal to -3.9. If you are not comfortable doing that subtraction in your head, like write it down, use a calculator, whatever. It's about -3.9. And divide by -4, so x is approximately equal to -3.9 over -4, which is about 1. I don't know if I'm comfortable calling it exactly 1. That's be what, 1.025, something like that. So 3.9 over 4. Oh, 0.975, right? It's smaller, not the other way around. Yeah, so 0.975 is about my answer. So let's write that down as my answer. X is about equal to 0.975. Okay, so if I were to take 0.975 and put it in there, let's see what happens. I'm going to do 2 to the 6 minus 4 times 0.975 and do all the rest. See what I get. Well, that's a bit to remember. Sorry, 7 times 6 minus 4x. Okay, so we're going to do 6 minus 4 times 0.975. We get that. Then I was going to raise 2 to that power, to the power of answer. I suppose I could just type 2.1, but whatever. 2 to the power of answer, and then we do times 7, and then minus 11. And we were supposed to get 19, and lo and behold, that's basically 19. Only error due to rounding error. So that looks like a good answer to me. Cool. So yeah, you just treat this like any other equation to get it down to just the exponential equals a number. Then you use the power property and solve that way. There you go. That's how to do them. Let me show you log equations. So one of the problems you'll run into if you go Google solving log equations is that they will use a bunch of different properties that we didn't talk about. I do not care about those things. The thing I like, solving log equations is actually significantly less important than solving exponential equations, because log equations don't really come up very much in applications in general. You use logs to solve exponentials, but you don't really get a lot of log equations. You get a few when you get to calculus, but not even very many then. And so I'm just going to leave you to solve those then if it's relevant. And even then, it's really not. Anyway, I want to show you how to solve these. Basically, the trick is to turn them into exponential form and then solve. That really is basically what we're going to do here. So what I'm going to do is I'm solving log base 2 of 2x plus 1 equals 3. So what I'm going to do is I'm going to switch this to exponential form. So remember that this says that 2 to the 3 is the thing inside. So switching forms gives me 2 to the 3 equals 2x plus 1. 8 equals 2x plus 1. I suspect none of you will be significantly challenged by this equation. Subtract 1 divided by 2. So 7 equals 2x. X equals 7 over 2. Bam. Done. Same thing for the next one. A little fancier, but not fancier. It's messier. It's the same basic idea. So the thing you want to remember here is this is a natural log, so the base is e, right? It's not written there, so you gotta kind of tell yourself, what's my base when I don't see one? Well, if it just says log, your base is 10. If it says ln, your base is e. So this says that e to the negative 1/2 equals 3 minus 4t. That's what I'm going to do. I'm going to switch forms. E to the minus 1/2 equals 3 minus 4t. I'm going to solve for t. This is another one where it's 100% fine to just go ahead and get a decimal approximation right now if you want to. Absolutely fine. I'm not going to bother. I'm going to subtract 3 from both sides. So I'll have e to the minus 1/2 minus 3 equals negative 4t. Divide by negative 4. So we end up with e to the minus 1/2 minus 3 all over negative 4 equals t. Now that's a little bit messy. I'll show you a trick that you can do. Not exactly a trick, but a thing that you can do, which is to factor a negative out by switching the order of a subtraction. So the thing you want to see here is that if I have a minus b, let me go on to the next board for this to describe the trick. It's not particularly complicated. You may have seen it before. If I have a minus b, that's the same thing as negative 1 times b minus a. Those are the same. So what that means is I can get an extra factor of negative 1 by switching the order of my subtraction. So if I, just to put this in more concrete terms, if I have 3 minus 5, that's negative 2. That's the same thing as negative 1 times 5 minus 3, right? Which is negative 1 times 2, which is negative 2. Right? Those guys are the same thing. And all I did was switch the order of subtraction and add an extra negative. So, for instance, in this problem, the way I would write it, and the way every book I've ever seen would write it, is they're not going to leave a negative in the denominator. They're going to factor a negative out of the top and then cancel them. Right? So if you look at a book, the answer you'd see would be like this: 3 minus e to the minus 1/2 over 4 equals t. And that's how I would write it too, probably just because I've, spent so many years around other mathematicians who would do exactly the same thing. Yeah, that'd be my answer. Feel free to jam that into a calculator if you want. I guess I will. 3 to the minus e to the minus 1/2 over 4. All right. So we're going to have 3 minus e to the power. Oh, and the way you get e, by the way, in your calculator, it's the second function of natural log. Second function of natural log. This is negative 1/2 all over 4 is 0.598. Okay. So if you want, you can write this as 0.598. That's a fine answer. I'm prone to just stopping here if you want to get a decimal approximation, because you actually, like for instance, if you actually want to use this number for something, this is the more useful form, obviously, right? If you just want to show that you can do a problem, this is the probably better form. Anyway, that's all I really want to say about these. I don't want to spend too much time on them. Log equations are not the hugest deal. Exponential equations, on the other hand, are really, really important. And so you need to know how to solve those guys. Log equations, maybe it'll come up if you go to calculus at some point. But yeah, know how to solve exponential equations. The key there, take the log of both sides, use the power property to factor out the exponent, and then do whatever algebra you need to do from there. But that's the basic idea. All right, that is all I wanted to say about these, so I'm going to go ahead and stop the video.